So Sai, I got STYLEGAN2 running.
Great. So how are you doing with it?
Actually, I'm pretty bored of just generating random faces. Is there something else I can do with it?
I'm glad you asked.
This is the ultimate guide to STYLEGAN2 custom training. Here we go again. So, welcome to the most comprehensive step-by-step guide on getting your own images into a STYLEGAN2 model and training your own generator based on those images. I just got finished with the editing process, and the tutorial alone is almost twice as long as my setup guide for the STYLEGAN2. And this is mostly because I changed the recording. So what I did before was just do screen grabs and do voiceovers afterwards. And now I changed to OBS, which allows me to actually record my voice while I do all of this. So this has become a bit less scripted and more me actually doing my own workflow and explaining everything that I do and that I can accidentally go wrong along the way. Please leave a comment if you like this more or less than the original, and also give me a like for the YouTube algorithm. And without further ado, let's look at what we're actually talking about in this tutorial. So here's going to be an overview with timestamps again, and also in the description there will be a write-up with timestamps. So in this video I'm going to talk about how to pre-process your images. That means like getting them into the exact format that is required by STYLEGAN2. Then I'm also talking about how to do that the fast way. Then I'm talking about how to import these images into the STYLEGAN2 format, because they're using an optimized tfrecords format instead of working on the images themselves. Then I just talk about how to actually get the training running for the first time. And after that, I go into the case that, hey, you had to use your computer in another way or shut it down or do whatever with it. So you had to stop the training and you want to resume it later on. So I'm talking about how to resume your training the old-fashioned way in the NVIDIA code base. And then I'm also, in the end, talking about how you can resume the training a little bit more easier with a community patch written for the software. So, without further ado, let's get into the video. So here we are, just where we left off after the ultimate STYLEGAN2 Docker setup guide for artists. You can see here is our STYLEGAN2 folder. In the results folder, we still have the generated images that we created at the end of the tutorial. And now we want to create some new images that are not faces but have something more artistic. And for that, first we need some new training images. And I would like to introduce you to a very good source of training images. That is the open access at the Met. So the Metropolitan Museum made all images of public domain works in its collection available under Creative Commons 0, which means if we go into the collection search here and tick this box for open access, then all of these images we can use for our art, and that's perfectly fine. So I've already taken the step of downloading these images here so that we can work with them and process them. If you're interested in learning how I batch downloaded all of these, because obviously I didn't click on the images and clicked every single, download link here myself to download the image. I obviously wrote a script to do that for me, and if you're interested in that, please leave a comment and I will cover that in a future video. So, back to the data set. We have this data set, we have these images here now, and how do we actually use these images for a new STYLEGAN model to generate new artworks that are kind of similar to the Metropolitan collection, but not really. So the first step in that would be to actually pre-process the image sets. STYLEGAN has, or STYLEGAN2 as well, has some prerequisites to the images. In the vanilla version of STYLEGAN2, they all have to be of square resolution. So for example, 512 by 512 or 1024 by 1024. It has to be always square, and it has to always be a power of 2. So 512, 1024. If you have less GPU, then maybe start with 256 by 256. But in general, that's how we need the images. And also, there's a really, really dangerous trap that I fell in way too many times. And that is, every dataset has black and white images. No matter how colorful you think the images are, there's always a couple images that are just black and white. It's kind of obvious here, but it happens so often. And even if you just extract frames from a movie, the cut where it's like a black frame for like, literally just one single black frame between a cut, that image can be encoded in grayscale instead of RGB, and that will mess up your data set. So to find that out, you can go to terminal, and then you can just say identify, which is part of the ImageMagick suite, as you can see when I ask the version. And if I just say identify the first image, it will tell me all kinds of good stuff, and also grayscale. Grayscale is not what we want. What we actually want is the sRGB color space. That works much better in STYLEGAN, and the real problem is if you mix two different color spaces, it will just crash and burn and nothing works, and you have no idea why. So that's why your dataset crashes. We need to first convert everything into square with a power of 2 resolution and an sRGB color space. So that's our first goal here. I've downloaded these 500 first images of the dataset. This dataset, as you could read here, has like more than 400,000 images, but for demonstration I only work on 500 because otherwise this video will take way too long, or it's just boring to see the images being processed. So if we go back to the terminal, now that we have identified that there is grayscale and sRGB and all kinds of different shapes, so what we want to do now is to get everything into 512 by 512 square resolution and convert everything to sRGB color space so that it's uniform across all images. In order to do this, I have this wonderful silver bullet that I've created during my time of working with datasets. That is to use mogrify, which is also a part of the ImageMagick set. Quick side note, for me ImageMagick just came with a new Ubuntu 18.04 installation, and presumably with newer installations too. So no further installation required. You can just use identify and mogrify as is. And in order to convert all these images, I have over time created the following silver bullet command that just works tm, which is mogrify minus verbose to say, tell me what you're doing, minus type truecolor to say, hey, convert to sRGB color space, minus format JPEG to use images in JPEG format, and then for automatically cropping the center square, so on this image it will be probably like this square, like this part of the image, and here it's this part of the image, kind of, and here it's just like the square but resized. We're using the command thumbnail 512 by 512 head gravity center and extend 512 by 512. So this is the full command, and we're just going to demonstrate what this does on the first image. And as you can see here, we just cropped out the center square. And if you remember, we had it as a grayscale here. If we use identify again, it is now also sRGB and also the right resolution 512 by 512. While it was 2157 by 2724 before. So this command works, and now obviously we can like use it on every single frame. So we could go on, and we converted the second one. What we actually want, and for this I'm gonna do a copy of the folder so we can have the originals. So I'm now in the copy here, and what I'm now gonna try is just use mogrify on everything. And as you can see, it just like goes through them. They are sorted a bit weird because I didn't put in leading zeros, but it just goes like image by image, and that's cool. Also note that if we run it multiple times over the same image, it doesn't really do anything because it's already 512 by 512, and it also doesn't break anything, so kind of good. However, this goes image by image, and if we set up another terminal and use htop, which we don't have, so we just install it. Typo, sorry. So we install htop, which is a process manager that should tell me how my CPU is actually used. So if I use htop here, let's put this down here. That actually works better than expected. I kind of expected it to not parallelize like this. So if we pull up htop, then we can actually also see that mogrify makes a lot of threads and automatically spreads it across all of my CPU. So I honestly planned on introducing parallel in this video as well for process parallelization, but apparently that's not really necessary since mogrify also already spreads my threads pretty well and uses all of my CPU apparently. But yeah, so just for fun, we're gonna do another copy of this. And I will introduce you to Parallel anyway. So Parallel is a really cool program that I don't have installed yet, so I'm just gonna do sudo apt install Parallel. Yep. And the whole idea behind Parallel is that you can give it like multiple similar commands and it just automatically spreads them up in different threads and runs them in parallel. That's all it really does. So if we just started without commands, it also says please cite this in case you're using this for any kind of academic work. Since we're not writing a paper, we can ignore this and run parallel citation to promise that we will cite it if we ever write a paper, which I absolutely will do. And if anyone's interested on YouTube, this is the actual citation. So it's part of the video now. I'm safe, I think. But yeah, it only applies actually for written academic papers. So we use this by giving a list of stuff into Parallel and having Parallel apply this list of stuff onto commands and slightly changing the command for every instance of the list or every entry of the list. So in this example, we can use ls-1 to just get like the file names on separate lines in this here. And that we will use to say ls-1 pipe to parallel. And then we copy our mogrify command, paste it, and where we had the wildcard at the beginning, we now put the placeholder. And what this will do is it will take a name of this list, put it in here, and start this conversion process as a separate thread. So that's why we have this secondary copy. Let's execute it and see how it compares CPU-wise. And now we actually get like 100% load on every single core. If you really need all the performance and process a big data set, this is still a bit more efficient, and I would recommend using Parallel. And also, of course, if you ever do academic work, cite it and support it. This is basically all my favorite pre-processing work. Obviously, you run into some problem with like stuff that is cut out not optimally. But if you just want to go for like general feel of the data set, then I feel like cutting out a center square like this out of the painting actually captures the essence of the painting for the data set quite well. And if we actually have like images like these, it just works perfectly. And we can see if we identify number 6, it's exactly 512 by 512 in sRGB. Everything that we want, and it's like also pretty perfectly cropped. So let me refresh the thumbnails. So I'd argue for this data set, it works reasonably well. But if you have some differently aligned data or images, then you might want to look more into manual working with the cropping so that it makes a bit more sense. But here I'm quite happy with the center crop, honestly. So yeah, we'll just use the center squares for our images. Good. So now that we have the pre-processing done, we can go back to StyleGAN. And if we remember correctly, we set up this nice alias of ndocker StyleGAN2. That just brings us back into our environment. And now we are going to use the we're going to load the image set into StyleGAN2 format. So StyleGAN2 doesn't work directly on images. It actually compresses the images into a tfrecord. as you can read here under preparing datasets. So what we do here is this command, Python dataset tool py, create from images, and then we give the dataset path, which is where the tfrecords files will be saved, and then the path to the images. So first of all, we of course have to navigate to the STYLEGAN folder again, and then we say Python dataset tool py, create from images, and this should be now under home image sets met 500. Let me just check if this one is, oh, let's use the one we created with parallel for this time. Oh, my bad. This is of course the images, which is the second argument. I kind of always make this mistake, so it's always good to read the documentation and see that the images are actually the second argument. And we're going to put the tfrecords file in home datasets met 500. Now we let this run. And it works reasonably fast, especially on the small data set. Great, and now we can go here and see in datasets met 500. We have actually created these tfrecords here, and they go from 2 to 9 because they save the images in all kinds of different resolutions, which are denoted by the power of 2. So 2 to the power of 9 is 512, so it goes up to R09. So these are like all the images in all the different resolutions. So they are downscaled up to the level of 4 by 4 pixel, which is 2 to the power of 2. I also have here like bigger data set, which is the an old MET that I already have on my hard drive that I might use for demonstrations later. And this MET 500 is the one that we just converted out of these images. So now that we have created our data set from the images, the next step will be to train the actual network. For this, we use these commands here. So in our case, this would be Python run training. Num GPUs is 1 for me and probably most people who use this. The data directory is home datasets, and that's it. The data set, I'm deviating from the order a bit to keep it together, would be MET 500, which is the metropolitan images that we just processed. I like to put data dir and data set together because that's kind of the full path. Then the config means how. So for the config, there's config A to F, which are progressively more difficult neural networks or more sophisticated neural networks. I'm saying difficult because they all take also progressively more RAM. And I can personally only run the config F in 512 by 512 as a maximum resolution. And that already takes all of my 11 GB graphics card. On config E, I can make it up to 1024 by 1024, just about. You can also see like some estimations on how long stuff takes and how much RAM you need down here in this table. So the most reasonable is like config F at 512 or config E at 1024. There's also the possibility to use floating point 16 instead of floating point 32 variables. That reduces the memory footprint and actually allows you to run in a higher resolution than you could naturally do. This was shipped by default in the progressive GAN, and then I believe Vector was his username, ported it to STYLEGAN1, and I think he also has a fork of STYLEGAN2, or a branch at least, where the floating point 16 is enabled. So I'm probably gonna talk about that in some other video if people are interested. But for now, let's just go with config F. And then the last argument that we need here is total kImage, which is kind of just the goal iteration where we want to stop training. These numbers here are pretty high. I feel like you get pretty good results with already like 10,000 iterations, and like that's something that is still like almost reasonable. Like it should take about a quarter of this, so like, I don't know, a week of training maybe, or oh wait, that was config F. Yeah, it takes a while. So somewhere between this and this, we are with a 512 on 10,000 iteration. I feel that should be enough time for training. I didn't put the dashes. Well, typos happen. Okay, so now the training is running and we're gonna come back sometime later. So as these messages tell me, we're already kind of short on memory. When these messages come, you're still okay. It says it tries to allocate, blah, 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 but that is not a failure. There could, however, be performance gains if more memory were available. Which means, yep, training STYLEGAN in 512 or higher is kind of luxury. And even on relatively good consumer grade hardware or high performance gaming hardware, it takes a while. Just get used to that. But it's very well worth the wait, in my opinion. So let's go back to our STYLEGAN2 folder and look what has happened here. So this is all debug information about the network. As artist, I'm not really interested in the details of the network, to be honest. So this is the new folder that we created now. It's the STYLEGAN2 MET500 1GPU config F. And here we can see this is the target data set. So this is what STYLEGAN2 will try to imitate with the generated images. This is just a snapshot. Of course, this is not all the images it compares against. It's just a random sample of our data set. And here we can see the initial image generation of STYLEGAN2. So at the start, basically at iteration 0, it has no idea how images are supposed to look. And this is basically just the raw potential of the neural network, which in itself I find quite fascinating and nice to look at, especially if you render a video out of just this. But yeah, this is just like random colors that are a representation of the uninitialized neural network. So now we wait a little bit until this has trained for a while. And then we can hopefully see that we get some nice images out of it that resemble the metropolitans. So while we go through a time lapse of the training process, as you can see, if you look to the clock at the top of the screen. So tick is basically just how far we got, so a bunch of iterations. K-image is how many thousand images the network has been trained on. Level of detail, or LOD, is a legacy value that you can ignore. Mini batch is how many images are processed at once on the GPU. Time is obviously the current time that it already trains. Seconds per tick is how long it takes for one iteration. Seconds per K-image is how long it takes for 1,000 images. Maintenance, I'm actually not sure about what it means. And GPU mem is obviously how much VRAM you use during training. So let's look at the images this training has produced. This is the very initial image from the uninitialized network. Then we have this one, which is after 10 ticks or 60,000 images of training. You can see that it kind of picks up a similar color temperature or color grading than the museum pieces. Then a little bit further, after another 10 ticks or 120K images in total, we can see it actually starts picking up shapes a little bit. Some of those actually look like coins now, and if we go into the direct comparison to the real samples, these images are quite large, like multiple thousands of pixels wide and high, so it takes sometimes a little bit to load into an image viewer even. But now in the direct comparison with the real images, we can see that especially the coin-shaped objects are kind of almost recognizable already. So if we look at the console, we see that we just reached tick 30, which means it should render a new image any moment now. And there it is. So we just got a new network snapshot here and a new image. And if we look at that, we can see that it quite improves a lot with every 10 ticks or so already. So every like 3 hours or so. So unfortunately I had to use my computer for something else and actually switch back to Windows for that. So I had to stop the training, which however is a great opportunity to talk about how to resume training. So this is the folder that we had last time, where we had all the results and where our training was happening. So as we can see, we produced like these images here, which gave the current standoff or the current snapshot sampling of what the AI model thinks metropolitan artworks kind of look like. And along with that, we also produce these network snapshot pickle files. And these actually are the save points from where to pick up your training. And these are also the files which you use to load the model when you want to render out images or videos later. So let's take a look back at the STYLEGAN2 over here. And these are the commands that we use to start training. Unfortunately, on this page, there's not really any mention on how to resume the training from a previous snapshot. So to actually resume the training from a previous snapshot, we have to look at the code of STYLEGAN2 and make some small changes over there. So while you could use Nano or any other text editor that you have on the machine already, I prefer to have something with a bit more syntax highlighting and easier code navigation. There's lots of good alternatives for this, like Sublime, Atom, PyCharm. But recently, I've become kind of partial to Visual Studio Code. I've worked a lot with that in other projects and I kind of like it. So let's go to the Ubuntu App Store and look for Visual Studio Code. And as I said, Sublime Text and PyCharm just are the next two, just interesting. So I'm just gonna install Visual Studio Code here. So now Visual Studio Code has installed. Let's launch it. So we're just gonna open a folder and select the STYLEGAN2 folder as a whole. So here we are. Now maximize this and let's actually look at the run training script that we've been using so far. So if we scroll down a little bit, we come to a main. That is actually where the program starts when we invoke the command line with a Python run training py. And here we see the list of all the arguments that we can use on the command line. So the first argument is just result dir. This one is kind of not interesting. It's just where do you save all the data that you create during training. The second and third one are data dir and data set. This is where we point the program to the MET500 tfrecords. The next one is config, which, as I explained earlier already, is what kind of network are you using to train STYLEGAN2. Config being the most difficult and most sophisticated, but also probably the one with the best results. And there's more details to go into here, but we just use config F or E and be fine with that. Num GPUs is how many GPUs you have. Total K image is just at which iteration do you want to stop training naturally. So you can always just like let it run forever and see what happens. But this means like at this iteration we just stop training. And iterations are measured in thousands of images. So your network is shown, for example, 180,000 images and learns from them. That means 180K images. And the usual training duration is like 10,000 K images, so like 10 million images. Gamma is some really technical detail about how the network behaves. We can just set that as default, and I haven't played around with that. Mirror augment will create virtual copies of all your images that are flipped horizontally, so left and right is switched around, and then use that to train too. Can be helpful if you don't have enough faces or something to train on. And then the metrics argument is used for, well, using metrics that are some kind of visual differences or some formula to calculate how well the images you create with the new model fit into the original data set. That's usually just used for painting nice graphs in academic papers, and it doesn't actually help us. And furthermore, it actually costs some training time because it always costs a little bit of time to calculate all these metrics. So what we should do is set this to none, which I actually didn't do in my first run training. So maybe if we go back to this STYLEGAN2 log here, actually, I just realized I could have just opened it in Visual Studio Code as well, because this is all in here. So here's our log file. We can see that here we have this FID 50K, which is the metric that we computed. And we can see we actually wasted like 16 minutes. It's not a lot, but you could have used that time to calculate some other steps, like here it takes usually like 20 minutes to go from one tick to the next. And then here, from here to here, we have like 36 minutes because we calculated these metrics. And that costs a bit of time, so we probably don't want to do that. So these are all the commands that we can use on the command line to change up what the training does. And none of them actually lets us resume training. That is actually hidden in the training loop. So if we scroll down a little bit, here we have this training loop that actually defines how the training is working. And some of these, like total k-image and mirror augment, are actually available here and get passed through. However, not all of them are. And the ones that are actually interesting for us for resuming training are resume pickle and resume k-image. Those govern how the training actually proceeds. So what I'm gonna do is I'm gonna open up here our file. So how do we use all these variables now, and how do we have to edit them to actually continue the training? So first of all, in resume pickle, we have to give him this file, which is our latest snapshot pickle. And in order to do that, we have to give it as an absolute path. Now, we remember that in our Docker container, this whole thing is mounted under home. So our home is actually like /home/Cyremore on our hard drive. But because of the Docker redirection we do, this is then in the Docker container actually mounted under /home. And then in STYLEGAN2 results, and let's copy F2 for rename. We copy this folder name. And then F2 again, we copy this file name. So that would be the correct path to the resume pickle. And for the resume k-image, we can use this 180 here. If we want to be a bit more precise, we can also look in the log and see that the exact number for k-image is 180.6. So let's just use that. And then we hit Control Save to save this file. And while we're in here, we can also go to run training and set the default for the metrics to none. So we don't waste any more time on metric computation because we're not really interested in that. We're just interested in doing something with the images that are actually rendered out. So let's close this and go back to our terminal with the STYLEGAN2. So let's go to home, STYLEGAN2, and we don't go into results, we stay in the root of STYLEGAN2. And now let's look again at the arguments here that are actually needed. So the ones that we actually have to give are the ones with required true. So result dir, we don't have to mention data dir, and data set we have to mention actually. So run training, data dir is home datasets, data set is met 500, config is also required, so that is config f. Num GPUs is actually not required and has a default of 1, so that's fine. Total k-image is not required, has a default of 25,000. It doesn't really matter what number you need here because you usually just let the training run until you manually stop it. So I'm just gonna leave it as is. Mirror augment, default false, yeah, that's correct too. And then metrics is also not required, and we just set the default to none. And save this file. So that should do the trick now. So editing voiceover, I accidentally introduced some white space changes in the code here, which broke the Python formatting. I solved this by doing basically undo or Control Z until I was back at the original file, and then I just changed the variables again and saved, and it worked. So that's what I recommend to do if this happens to you. And through the power of editing, I will take you now to the working version in 3, 2, 1, and execute this command here now. And it will create a new directory, results run number 3. And now it will hopefully tell us that it loads this network from our second run that we already have here. So very nice. It found our snapshot here and loaded the images from that. Let's go into the new folder. And here it starts setting up the run folder the same way that it started to do that when we initially started the training. And here's our initial version of what it believes looks like metropolitan images. And this is kind of where we left off with our last training session. So that worked well. And now we can resume training from that point in time. We have again the same warnings that we are a bit short on memory, but it still works, albeit a bit slower. So everything as usual now. And then I think I'm just gonna let this train for a while and show you one more iteration, so one more tick, which would be in about, well, no, one more tick. So as you can see, it just created another snapshot at fakes 180. So it does indeed pick up at the state that we just left off in the last training. Here's again the state of what it thinks the metropolitan images should look like. So now I'm gonna let this just train for a while. So if I remember correctly, one iteration was 20 minutes and the next network snapshot would be at 10 ticks. So 10 times 20 minutes is like 200 minutes is like 3.5 hours, kind of. That's a bit long, actually. So let's have another look at the code. This is also governed in training loop. So we have this argument here called here's the piece of the code that says save snapshots. So the network snapshot ticks should be 0 or done. And then it saves the next pickle. So what is this network snapshot ticks? It is 50. That doesn't really make sense. Because it saves. Now, here in the, so what I just did was I looked at the variable and I wanted to find out if it is set at some other point. So what I did is a full text search on all the code files. And I found that this is also mentioned in run training. And in run training, we can see that the train image snapshot ticks and the train network snapshot ticks are both set to 10. That aligns more with what we experienced with our previous training, where we had a model snapshot and a image snapshot every 10 iterations. So what you can do if you want to save this more often, you can set this to a lower value, say like 1. If you're like afraid of a power outage or just want to save as often as you can to not miss any progress whatsoever, you can also set this to 1. Then it will save about every 20 minutes to half an hour or so, depending on configuration and hardware and everything, of course. But yeah, here's how you can set the configuration on how frequently you want to save. This is all you really need to know how to continue the training. So I'm not going to let this training run further right now, maybe later on. For now, I will stop the training with Control-C, as you stop most programs, and instead show a way to make this whole resume from training a bit easier without going into the code every time and edit something there, which is a bit cumbersome, to be honest. So, as we can see on GitHub here, there's pull requests. And here's one that has the really nice title of Add a Resume Training Arcs to Run Training. So, someone actually put in the work and created a patch to this that enables to give these resume pickle and resume k image arguments that we use to tell the network where to find the snapshot and where to continue from, and put it into the command line arguments, as you can see here. And that's really helpful. So let's get that code. All you really need to do is to clone their repository instead of the official NVIDIA STYLEGAN2 repository. So let's do that. I'm going to go to my home folder. I'm going to rename this to the classic old STYLEGAN. Then I will open a terminal and git clone this version, which really is the same as the NVIDIA version, plus this one commit here, or patch, that you can use the resume arguments from the command line. So, if we now open Visual Studio Code, it should actually point to the new one, and yep, it has already loaded. As you can see here, this shows you that something has changed. As you can see here, the train resume pickle are now here. So this file can now change these arguments. And if we scroll down, they are also added as the command line arguments. One little change, since we checked out the new repository, we have metrics again. So let's just disable this again and save. And in the training loop, we are back to resume pickle none and resume k image as 0 for the fresh data set. And what we can do now is actually let's use the inbuilt terminal. So we can do this all on this one screen. So we can do ndocker STYLEGAN2 here. This is the same terminal that we had here. Just now it's all in one window, which I like. So let's go home, STYLEGAN2, and now we are running the run training again with data, dear home data sets. Yep, and data set is where the MET 500 belongs. I'm not sure if you need the equal signs. I think it works without or with them. I'm going to leave them out for now. And then the other part that we need is require to config. Config is config f. And now we're going to say resume pickle, which will be home style old STYLEGAN2 results. Oh, we also have tab completion here, which is really nice because now we're on bash level, and the bash actually knows our folder structure, which is a bit of an advantage over just like putting in path in a text editor that doesn't know that we're putting in a path and doesn't have tab completion. So this makes it a bit nicer here. So home old STYLEGAN2 results is where we just moved our results, and it was run 2. And then it was network snapshot, and this should end in 180. Perfect. And then we say resume k image, and the number was 180.6. And now we create a new folder. In this new folder that we just opened up, so we kind of reset STYLEGAN2 because we moved all the stuff we did earlier to old STYLEGAN2, and now we have a new STYLEGAN2 folder, so this is run 0 again. But still we can load the networks here from our snapshot. And this is some initial plugins that need to be compiled on the first run, since we have a new STYLEGAN2 folder that has to be done again. This will be cached later on, and you only see that really once. These plugins are made by NVIDIA and kind of increase the performance of the STYLEGAN2. So here's the debug output for the network again. And we should now be training any minute. Dum dum dum. So yeah, we're building the TensorFlow graph again, as we did earlier in the terminal here. And the next step will be initializing logs. We can actually look into the results folder here. So we made a new results folder. We have the reals, we have the fakes in it, which is a sample rendering at the very beginning of the algorithm. So let's close this terminal now. And this terminal. And all we really need now is Visual Studio Code and this folder view here. So yeah, the training has started again. We get the same old messages about just having enough VRAM to run it, but we could improve. And now we have the confirmation here that it indeed starts training again at 180.7K images. So yeah, this is basically all you need to know about resuming training. Now, how you use this on your own, which editor you like, if you want to take this community patch, that's all up to you. But now you should know everything that you need to actually train STYLEGAN2 on any image set that you can imagine. So, enjoy your training, and may your GPU be always well cooled. So, that was a quite long video. I hope I could answer all questions that could possibly come up during the training process and fully enable you to now make your own STYLEGAN2 model. Feel free to share any results or just give me comments below. And also please like and subscribe if this was helpful. I'm trying to probably publish a video twice a month and go a bit more in depth. The next video would then be on rendering videos and images from STYLEGAN2 and what you can do with that. And if you start now, you could have your own model trained by now. So that's some incentive, I guess. If you want to see more of my work, you can also follow me on Instagram @Cyremore. And if you want to further support this channel and like what I do with the tutorials that I put so much effort into, you can also support me on Patreon. And if you have any further business inquiries like commissions or consultations, this is the email where you can reach me. And lastly, just thanks for watching.